Hey, scholars! Welcome to Mathora. I'm Ms. B, and you'll be learning with me. Today, we're learning the 8 exponent rules. Go ahead and grab your pencil and paper. First, what is an exponent? Most people look at these examples and say all of these are exponents, but that's not exactly correct. We have the base. The base is the number. It can either be a variable or actual number. So here we have x, a, and 5 as our bases. Then we have the exponent. And so the exponent is a small number at the top right of the base. And it tells you how many times you multiply the base. And altogether, it's called a power. So for example, the first one is x to the power of 2, a to the power of 2, and then we have 5 to the power of 2. Rule number 1, the zero exponent rule. Anything raised to the power of 0 is 1. So here we have the formula a to the power of 0 equals 1. Let's look into some examples. We have x to the power of 0 equals 1. We have 5 to the power of 0 equals 1. So no matter what the base is, if your exponent is 0, your answer is 1. No more exponents, just the number 1. Now let's get into rule number 1.5, because this is the hidden rule that you don't normally see. What if you don't see an exponent? Most people will be like, well, I'll just put a 0 because 0 means nothing. But no, if you don't see an exponent, it's 1, not 0. So if you ever see a base without an exponent, we have to assume that it is 1. If it is 0, they will always tell you that it was 0. Let's get into some examples. So anything raised to the power of 1 is the base. So x to the power of 1 is x, 5 to the power of 1 is 5. That's the hidden rule that we don't really talk about. Rule number 2, product rule. Whenever we have the same base and we're multiplying, we're going to be adding the exponents. So here we have the formula a to the power of n times a to the power of m equals a to the power of n plus m. Let's look at some examples. Here we have x squared times x to the power of 3 equals x to the power of 5. So as you can see, we kept our same base of x and we added our exponents. 2 plus 3 equals 5. Let's do another one. 5 to the power of 2 times 5 to the power of 3 equals 5 to the power of 5. Once again, we had the same base, and so therefore we kept our 5, and 2 plus 3 is 5. Really? Your answer is 3,125, and this is how it works. 5 to the power of 2 is 25. 5 to the power of 3 is 125. If you multiply 25 times 125, you get 5 to the power of 5, which is 3,125. That's another lesson for another day. Rule number 3, quotient rule. Whenever we have the same base and we're dividing, we're going to subtract the exponents. So we have a to the power of n divided by a to the power of m equals a to the power of n minus m. Notice it is the first exponent minus the second exponent. You cannot flip this order. It also might look like this. A to the power of n over a to the power of m equals a to the power of n minus m. Once again, it's the top exponent minus the bottom exponent. You cannot switch the order. Let's look at some examples. We have x to the power of 3 divided by x to the power of 2 equals x to the power of 1. Now, what we just learned from the hidden rule, we know that our final answer is x, but that is another video for another day. Once again, it also might look like a fraction. It says the same thing. X to the power of 3 divided by x to the power of 2 equals x to the power of 1. Rule number 4, power of a power rule. So this is when you're going to have the same base. It's usually going to be like one base, and you're going to be multiplying the exponents. So we have a to the power of n to the power of m. So whenever you see parentheses and you see exponents, kind of think of the parentheses as a multiplication sign, right? So our answer is going to be a to the power of n times m. Let's look at some examples. So x to the power of 2 to the power of 3. We're going to keep our same base, x, and we're going to multiply our exponents. 2 times 3 is 6. So our final answer is x to the power of 6. Another example, y to the power of 5 to the power of 2. We're going to keep our base of y, and we're going to multiply our exponents. 5 times 2 is 10. Our final answer is y to the power of 10. Rule number 5, power of a product rule. So it's really similar to power of a power rule, but this time we have products inside of the parentheses, which means we have two bases. So we have different bases. We're going to distribute the exponent to each base. So in our formula, we have a times b to the power of n. What we're going to do is we're going to separate the bases and we're going to apply the exponent to each base. So our answer is going to be a to the power of n times b to the power of n. Let's look at some examples. x times y, or you can say xy, to the power of 3. Our final answer is going to be x to the power of 3 times y to the power of 3. Now we have 3 different bases. We have 5xy to the power of 2. Your answer is going to be 5 to the power of 2 times x to the power of 2 times y to the power of 2. It is really important that we distribute that exponent to each base. So your real answer will be 25x squared times y squared. Rule number 6, power of a quotient rule. Once again, we have different bases, yet we're still dividing, but we also see parentheses. So whenever you have different bases, you're going to distribute the exponent to each base once again. So we have a divided by b to the power of n. Our final answer is a to the power of n divided by b to the power of n. Or it might look like a fraction. A over b to the power of n equals a to the power of n over b to the power of n. Let's look at some examples. Here we have x divided by y to the power of 3. So our simplified answer is going to be x to the power of 3 divided by y to the power of 3. Most likely, you'll see the problem written the second way, x over y to the power of 2. Our simplified answer is x to the power of 2 over y to the power of 2. Rule number 7, we're almost done. And this is my favorite rule, negative exponent rule. It is so easy. Watch this. Whenever you have a negative exponent, you're going to flip it and make the exponent positive. Boom, you're done. So in our formula, we have a to the power of negative n equals, and when I say flip it, I mean turn it into a fraction. We have 1 over a to the power of positive n. So whenever you have a negative exponent, you're going to take that power, which is the base and the exponent, you're going to put it in the denominator, make your exponent positive, and put a 1 on top. Let's look at some examples. Here we have x to the power of negative 2 equals 1 over x to the power of 2. We have x to the power of negative 3. That equals 1 over x to the power of 3. Last but not least, the fractional exponent rule. Whenever you have a fraction as an exponent, your answer is going to be written in square root form. The bottom becomes the root and the top becomes the exponent. A to the power of n over m equals square root of m, a to the power of n. Let's look at some examples. Here we have x to the power of 1 over 2. So the bottom becomes the root, which means it's going to be written on the outside. We're going to keep our base of x, and our exponent is going to be the top, 1. So we have square root of x to the power of 1. Let's do one more. We have x to the power of 2 over 3. The bottom is going to become our root, so 3 goes on the outside. We're going to keep our x as our base, and our exponent is going to be 2. So here we have cube root of x to the power of 2. And that's all of the exponent rules that you need to know. If this made sense, you're already ahead. Next video, we're applying all of these rules to real problems. Make sure you subscribe, like, and I'll see you in the next lesson. Bye!